Okay, well, I just had to restart the recording. Sorry about that. Obviously, you won't hear the bad part, but I started going in a couple of minutes and forgot to turn the microphone on, so it would have been a silent lesson. That's good times. Okay, three-dimensional shapes. We see them everywhere. We see cubes, we see cones, we see cylinders. So let's take a look at a couple of them. Okay, let's take a look at that one. Boy, I sure am a good drawer. Well, just free-handed that one right up for you. And so, just kidding. That's a cut and paste. So that's a pyramid, and it has a base of five sides. So it's a pentagonal pyramid. Okay, a pentagon on the bottom. So let's label a few things. Let's say let's see what I can write on here. That's going to be A. That's going to be B, C, D, E. Okay, so it should have 5 because it's 5-sided. And then let's say this up here is F. Okay, so it has a base of A, B, C, D, E, F. That's what it sits on. And then it has a point of F at the top. Excuse me, A, B, C, D, E. I'm not sure exactly how I said that. A base of A, B, C, D, E. So this is going to have different things. It's going to have a base, a face. Let's go over here, and we're going to go with base, which we just identified would be A, B, C, D, E. Okay, because that's what it sits on. Okay, and then it's going to have a face, or faces. All right, and the faces are if we took each individual piece of it other than the base. So let's look at the front. Staring right at us is E, F, D. That would be a face. Looking in the back, we could have A, F, B. And we're just kind of taking the little cross sections. Then we would have B, C, F. And then we would have DCF. Okay, and let's see. Oh, I forgot AEF, didn't I? I sure did. AEF. However many bases it has, or however many sides the base has, that's how many faces it should have. So I have a pentagon, and so it's going to have 5 faces. Okay? We're also going to have edges. I'll go over here. Okay? Edges are going to be any line segments. So I have, let's just start at the beginning. I have AB, BC, CD, DE, and EA. Okay, those are my 5 edges that are on my base. And now I also have each one going to F. So that's going to be AF, BF, CF, DF, and EF. Okay, so lots of edges. Again, edges are just line segments on the shape. Okay, and then we have what's called vertices. I'll go over here for those. Vertices. Okay, vertices are where all the angles, or excuse me, where all of the line segments come together to form an angle. So I have an angle at A, I have an angle at B, I have an angle at C, I have an angle at D, I have an angle at E, and obviously I have a bunch of angles that come together at F. Okay, so vertices will be equal to the number of letters that you have on your shape. Okay, so bases and faces, edges and vertices. All right, and we should be able to do that with any shape. So let's Let's take a look at another shape. Let's take a look at this cylinder, and we're going to look at cross sections. If I were to run a line through this and cut it in half, if I was to play like Fruit Ninja on this thing and take my samurai sword and cut it in half, there's two different results I would get here. Okay, if I Fruit Ninja this thing right across the middle and I opened it up, okay, and I'm going to call this cross section number 1. All right, if I cross section that and went straight across, and I've got some 3-dimensionals that I'll show you in class tomorrow. This might be a little easier to see. Okay, if I cross section that thing, I'm actually going to get a rectangle. Okay, it's almost like cutting a watermelon in half. If you held it up and faced it, it would look like a rectangle. All right, and that's with a horizontal cross section. Now, let's take the same shape and this time let's do a vertical cross section. Okay? Now, think about that watermelon again, or a pop can, or anything. If I cut it down vertically, this is going to be cross section number 2. If I cut it down vertically, what is it going to look like? Obviously, it's going to look like a circle. So if I cross section it horizontally, it's going to look like a rectangle. If I cross section it vertically, it's going to look at it like a circle. So two totally different views of this, almost like a dissection. Okay? So we'll focus on a lot more things in class. We'll talk about it just a little bit, but that's a good jump start on what you need to do. And so 3-dimensional figures in class tomorrow. We'll see you then.